Hello students, uh, I welcome to the course that is 2 week certification course on PLC, HMI and SCADA for the students of Electronics and Communication Department, BGS Polytechnic. Uh, as a part of the course, I have given assignment in the class, that is assignment number 4, uh, that is control of LEDs using timer and counters both, right? So this is a problem statement. So there are two push buttons like start button and stop, and there are three LEDs like L1, L2, L3. By operating the start button briefly, L1 should blink for 10 times. 10 times. But what is the frequency is? It is given here. Blinking frequency is 2 seconds. That means LED 1 should be on for 2 seconds, off for 2 seconds. Okay, so total duration for one cycle is 4 seconds. Okay, so this is what the problem. L1 should blink for 10 times and then L1 should go off. At the same time L2 will be on for 15 times, and then at last L3 will be on for 20 times. And this blinking of LEDs will be continue till we operate the stop button. So when stop button is operated, all the LEDs should go off. That is the logic. Okay. Here blinking frequency is 2 seconds, and here the task is we have to develop a HMI screen and PLC ladder logic, and we have to interface both this to get the final output. That means controlling of LEDs like L1, L2, L3 that is going to display in the HMI screen with the help of PLC program using timer and counters. Okay, I hope everyone understood the required output. Now before starting this PLC solving this problem or assignment, we should understand the problem carefully. So that is possible with the help of timing diagram. Before this here address is given here. I have taken start button to X0, stop button to X1, and outputs like LED 1 to Y0, LED 2 to Y1, LED 3 to Y2. If you want, you can change this address also. That is as per your convenience. You can take it. Okay. So according to me, start button is nothing but X0, right? So if you go to the timing diagram, on X-axis there is a time axis, and in the Y-axis there is a status of X0. X0 is nothing but start. Okay. If you want, you can also have a comment here. It is X0 is nothing but it's a start switch. So when you operate start switch briefly, that means you are going to switch on and switch off immediately. A pulse signal is generated here. After that, L1 will be on immediately, and it will be on for 2 seconds, and next 2 seconds will be off. So again on for 2 seconds, again off for 2 seconds. This cycle will complete, that is cycles will be n equal to 10 times. Okay, not this cycle here. N is nothing but how many times L1 is on. Okay, so L1 is 10 times on. Once L1 is completed this number of time 10 times on, then L2 should be on for 15 times, then L3 should be on for 20 times. Okay, but if you carefully observe here, one cycle, that means on and off. What's the total duration? On for 2 seconds, off for 2 seconds, total will be 4 seconds. So T2 will be 4 seconds. T2 is nothing but T1 plus 2 seconds. T1 is 2 seconds, so totally 4 seconds will be there. Okay, so this is a very important discussion. So once you understood this, on the basis of this, we're going to develop the PLC ladder logic. So let me open the software. So we are using WPL software. Double click on the software. go to file, new. I'll do it from the beginning. So click on S. So we are using SS2 PLC. So program name is, that is demo of blinking. Click on OK. And here I will take first normally open contact, that is X0. X0 is nothing but start button. I can put it in the comment section so that whenever you move cursor, and first of all let me zoom. Yeah, this is fine I think. So I've taken X0. This X0 is when you place a cursor near that, it will indicate that is a start button. Okay, so we want to switch on the coil, that is F7. I'll take one memory bit M0. It's a dummy variable. Okay, it is like also called as technical word is internal relay or internal marker, also we can call it, it's a marker. It's a temporary variable. You can also type like temporary variable. Okay, and I want to store the signal of start in the memory bit M0. So I will have M0 here parallel, and I will latch it. Click on here and then F9. Okay, so once you operate the X0, and then that signal is going to store in the memory bit M0 and continuously store because there is a latching. Sir, how can I switch off this? How can I erase the data of M0? Is nothing but by breaking the continuity. That means normally close. I'll take X1 and I'll label it as stop. Okay, this is done. So just to store, see, I don't want to operate this switch start continuously. I want to operate just one time, that is briefly. But that data should not be lost. So that is why whenever X0 is operated briefly, that data is going to store in the bit memory M0. Okay, continuously. So I know that M0 is on continuously. So what I'll do is I'll take normally open contact of M0. M0 is the basis for all our switching off LEDs. Okay, so M0 is on. Whenever M0 is on, what I'll do is I'll go for switching on Y0, that is L1. Immediately, there is no delay. When start button is pressed, L1 should be on immediately. So if you see the timing diagram, when X0 is on, immediately L1 is on. Okay, so it should wait for 2 seconds. It should be on for 2 seconds. After that, I want to switch off L1. Okay, so it will be on for 2 seconds. So what I'll do is, with reference of M0 again, I will take timer, that is F6 command application instructions, then type TMR, T and K, and here since first timer I'll name it as T1 and time I'll give it as 20. So that is please consider as 2 seconds. Click on OK. So what is your requirement? After 2 seconds, I want to switch off Y0. So when you want to switch off some output, you should use normally close. So what I'll do is I'll use normally close of T1 output. So LED L1 will go off after 2 seconds. But again M0 is a reference. But I will count the time again. I'll take one more timer, that is F6. We got as TMR, T, K, T2, total 40. That means 4 seconds. After 4 seconds, my requirement is again it has to switch on. It's very simple here. Okay, assume that. See, y0 is completely dependent upon m0 earlier, right? If m0 is on, y0 is on. But how I switch off y0? With help of t1, right? So if t1 is on, y0 is off. If t1 is on, l1 is off. After 4 seconds, that is after t2 giving the output, I want to switch on y0. So I have to switch off t1. Okay, so normally close of t1 so that it will start from the beginning, t2, and it should reset on its own. That means t2 should be reset again, because one cycle means cycle starts from 0 second. Okay, so after 4 seconds again t2 should be reset. So normally close, you take it, that is t2. Okay, so this is the logic here. Logic is here. Okay, I'm just step by step I'm developing it. Let me simulate only this portion of the circuit, the logic. So go to the simulation mode and then download the program and go to online, and it should be in run mode. Go to run mode, run mode, on, set on. So y0 is on, off, on for 2 seconds, off for 2 seconds. It is continuously repeating. Okay, but we are not counting the number of times on, right? So what we can do it is, we can come out of the online mode and simulation mode also, come out of it and then edit the program. Insert a row here. Now how many times y1 is on, that is L1, how many times it is on, I want to count it. So what we should do is, we should take normal, means here rising edge is better option. I want to count just on, not off. Okay, so rising edge, that is F3 is option, that is y0. I'll use F6 instruction and then type counter CNT, and then C, S1 is C, S2 is K. Since first counter I'll put it as C1, and then count it, I'll put it as 10. Okay, that is done. But after 10 times, y0, that is L1, should never be on again. So what I'll do is, I have to switch off using the counter value. So I'll take normally close, that is C1. There are two actions. After 10 counts, I want to switch on L2, I want to switch off L1. So I've just switch off L1 using normally close. I'll use one more instruction of C, that is C1, that is normally open contact, because I want to switch on. If you want to switch on, the normally open. So I want to switch on y1. But what I'll do is, always I'll take the reference of m0. So first I'll take m0. m0 is my reference. If m0 is on, plus C1 is on, what I'll do, immediately I'll go for switching on y1, that is L2. Okay, so what I'll do is, timer I'll use only 2, that is T1 and T2, because it is resetting after 4 seconds. Again it will count for 2 seconds, T1 for 2 seconds, T2 for 4 seconds. It will repeat it. So I'll use the same timer. So y1 should be off. Y1 should be off after 2 seconds. So I'll use off, means normally close, that is T1. Okay, so this will be repeated many times. Let us go through this. This much only I'll submit it. Go to simulate, download, then online. It should be in run mode. So I'll close this, all these things. I'll switch on X0. Now see the C1 value. C1, K2, K2, K3 actually means third cycle, third time, fourth time is on. Once 10 times on, that is L1, this L1. Once 10 times completed, Y0 cannot be on again because C1 is on. C1 is on means this will be open. So now it is L2, so L2 is going on, off repeatedly, but we are not counting the Y1, not counting the L2, right? So again we have to use second counter. So up to here it is fine. So what we will do is we will take another counter, that is we are counting, that is rising edge, again rising edge F3, Y1, and we have to use F6, and that is counter C and T, here C and K, and C2 here 15 times. Okay, so after 15 times what is our requirement? Y1 should not be on again, so normally close, that is C2. And another task is it should switch on Y2, that is L3, right? L3 should be on, but again our reference is M0. With help of M0 plus C2, we should switch on Y3, sorry, Y2, that is L3. Okay, now this will be done. So how many times I wanted Y2 to be on, that is L3, that is 20 times. So insert a row and it will take rising edge, that is F3 of Y2, and then F6 again, counter C and K, that is C3, and 20 times. Okay, right. So what I'll do is so after 20 times what should happen? It should means okay. So here Y2 should be blink, right? So again T1 should be taken after every 2 seconds. After every 2 seconds, L3 should be off. Okay, and after completing 20 times, it should never be on. So normally close of C3. Okay, and after 20 times that completes one cycle. So what I can do it is always M0 is on. M0 is always on because you are not operated X1. So if you reset all the counters, insert a row, that is C3 output, I will take it, C3 output I will take it to reset all the counters. So F6, go to F6 and then reset RST, you just type RST instruction, reset instruction, you have to reset C1, okay, plus we have to reset C2 also. So for that you first insert the row here, 2 or 3 rows you just insert, and then click on here, and there is an option called this option, draw vertical line and cursor move down, this option, and here you take F6 again and then type RST and then reset the counter 2. Again you click here and then draw vertical line and cursor move down option and F6 and reset of counter 3. So I've reset all the counters. Okay, so it will repeat the cycles. So what I'll do is I'll download the program first, simulation, and then download the program, and then online run. Okay, I'll switch on X0. So Y0 is on for 10 times. After 10 times, L1 is off, that is Y0 is off, Y1 will be on. Now L2 is on, that is 15 times. See, Y2, that is L3 can be on only when output of C2. C2 means counter. That means after 15 times only L2 can be on. Now K9 is there, K10. So you can also reduce, means increase the frequency by reducing the time. You can try with 1 second frequency. Otherwise it will take more time. Now last one, that is L3 is on. L3 is blinking. And same PLC program is downloaded to PLC hardware, and HMI screen also downloaded, and then that video you can watch it at the end. It's a laboratory video. Now 10 times completed, 11th time completed. Yeah. Now one cycle is completed, so now cycles are repeated. So again L1 is on. So cycles will be continuously repeated. So when we switch on stop button, is going to stop entire operation. Okay, so that is a working of this PLC logic. So now let us go to the HMI screen design. So that is the same design. One experiment is there, that is controlling of LEDs using timer. So same design, there is no change in the design. Okay, in recent files it's not available. So go to new, and we are using 107 BB model, and then next, and then RS 485 we are using it, then go to finish. So there it's very simple here. That means go to elements, you take some buttons. So we are using momentary buttons, 2 momentary buttons, and double click on this. Address should be, it is X0, and then style text, I wanted to name it as, it's a start. Even when it is on, I want to display as start. Picture, you can take the vector general buttons. You can go for this and stretch all and click OK. Double click on it, and then address is X1, and then text I want to display as stop. Even when it is pressed, I want to display as stop. In the picture, I'll go to vector, general buttons, I'll take red and stretch all, and then you can go for the light indicator, multi-state indicator, and I want to make it as 3 LEDs. So design, you just take any picture if you want, whatever you like it. Address is Y0, then text is, I want to display as L1. Even when it is on, I want to display as L1. Picture, you can take vector indicators, stretch all, this is L1, double click on it, then this one as Y1, text I want to name it as L2. Even when it is on, I want to display as L2. Picture, vector, then indicator. Take different colors. I'll take this, and I'll take this combination. Stretch all, and last one is Y2, text L3. Even I'll name it as L3 here. Picture, I'll take a different indicators. Okay, this one I'll take it. Stretch all. Okay, so you can take your own time and then design the screen nicely, and then you can download this screen to the HMI so that you will get the output. So output, you can see it in the last section. Okay, so this is how HMI screen can be developed. I cannot download because I don't have HMI right now. You can see it in the offline simulation, but you cannot work. Okay, the logic is not there. Yeah, this is what. Please continue watching the video to see the lab output. Thank you, everyone. In this video, we are going to demonstrate the assignment number 4, that is blinking of an
blinking of LEDs. 3 LEDs are there, L1, L2, L3. This is what HMI screen is designed. And here one more control is there. There are 2 types of control we are demonstrating here, that is PLC control and HMI control. PLC control means PLC will have input PLC inputs are there, right? X0, X1. So PLC inputs, by using PLC inputs, if you are controlling the process, then we call it as a PLC control. HMI control means by touch we can able to start and stop the process. That is called the HMI control. So both control we have designed. So that is what the HMI screen is designed for this application. So the output required for this assignment is by press of start button, briefly, L1 indicator should blink at a frequency of 2 seconds. It should blink for 10 times, and then L2 should blink for 15 times, and L3 should blink for 20 times. And these cycles will be repeated by till we operate this stop button, either PLC control or HMI control, both. Okay, so this is what the requirement. And right now PLC program is downloaded to the PLC, and HMI screen also downloaded to the HMI panel. And now we can able to control, see here, by operating the HMI screen we can able to start the process. That means L1 is blinking at a frequency of 2 seconds. And these are the students who developed the PLC program for this blinking of LED program. And PLC program I'm going to display, that is using WPL software. We have developed the program. This is a PLC program. Complete PLC program we can put it in the comment section for downloading this PLC program. This is a complete PLC program. And now I can stop the blinking of LED using stop HMI screen. I can also initiate the working using PLC inputs. See, PLC program started working using PLC inputs. PLC inputs means PLC control means either we can connect it to a sensor or real-time process. So that is a dynamic condition where controlling the entire process by receiving the PLC inputs. This is a part of 2 weeks training on PLC, HMI and SCADA. So students have developed the HMI screen as well as the PLC program.